So titrations, whether they're strong acid, strong base, weak acid, strong base, or weak base, strong acid titrations can be monitored using pH meters that actually give you the pH of the solution. There are also other compounds called indicators, acid-base indicators, that perform a similar function. They actually tell you based on their colors whether we've reached the endpoint or whether we've reached the equivalence point of that titration. Um, and by looking at the color. So we refer to that as the endpoint. So the endpoint of a titration is the point at which the color of that particular indicator changes color. So typically, your indicators tend to be a weak organic acid or base. Where the ionized and the unionized forms have different colors, right? So here H, this is IN, stands for the protonated or the unionized form of the indicator. And then in solution, it can lose that H plus to form the ionized form. So you can think of this as sort of an acid, right? And this is the conjugate base on the other side. And the important thing about these acid-base indicators is that these have different colors. So this one here, right, may be a particular color or colorless. And then the one on the other side, that has a different color. So we can tell based on the what's going on in the solution, that will have an impact on the color of the indicator. And that tells us whether we've reached we can visualize the equivalence point by looking at the color of the indicator itself. Different indicators have different colors and they change colors over a range of pHs. So for example, phenolphthalein, which is an indicator we use quite frequently in the lab, changes color from colorless to pink over a pH of 8.3 to 10. So it's pink in basic solution. It is colorless in acidic solution. Other indicators have different pHs over which they change color as well. So if you're doing a titration, right, and you know roughly where the equivalence point is going to be, we can select the most appropriate indicator to span that pH range of the equivalence point. All right, so for instance, the phenolphthalein that we looked at is colorless in acidic solution, but it's reddish pink in basic solution, and the pH range then would be between 8.3 and 10, where the color changes from colorless to reddish pink. If you have a solution where the pH is going to be changing, or the equivalence point is going to be, let's say, really acidic between, let's say like around 4, then something like bromophenol blue would be a little bit more appropriate, where it changes from a yellow to a bluish purple color, right? And that's a very drastic color change that can be noticed. And ideally, you want to select an indicator that has a very distinctive change in color across that equivalence point.